In this video, we're going to take a look at graphing the cotangent function. In the last video, we did tangent, and cotangent is similar. So we're going to start off by finding the values of cotangent at the quadrantal angles. So I have the cotangent of 0 radians, and remember cotangent is x over y. So for this one, it's going to be 1 over 0, so that's undefined. The cotangent of pi over 2 is going to be 0 over 1, which is 0. The cotangent of pi is going to be negative 1 over 0, so that's going to be undefined. The cotangent of 3 pi over 2 is going to be 0 over negative 1, so that's 0, and then back all the way around, cotangent of 2 pi. 2 pi is coterminal with 0 radians, so this is undefined as well. And when we were looking at our tangent graph, we stated that any x value that produces an undefined y value has an asymptote there. So at 0 radians, we have a nice asymptote. And then we also have an asymptote at pi radian. So I'm gonna mark that here. Pi and x equals 0. And I know that the label's here, half of pi. And this is going to be pi over 4. So this is going to be 3 pi over 4. All right, so this is going to be probably a period. So let's go ahead and I'd like to back off and go backwards and show another period as well. I want you to take a look. We still have the cotangent of 3 pi over 2 and 2 pi. I just don't have enough room moving forward on my graph. So I think what I'm going to do is I am going to go backwards, and since I only went to pi, I'm going to go backwards to negative pi and mark those out. So on my graph, I should have some equivalent angles. So if I go from 0 to 3 pi over 2 backwards, all right, so that's going to be a negative pi over 2. So let's mark that, negative pi over 2. And that's going to be equivalent to 3 pi over 2. And then if we keep going around and we hit negative pi, we come right here. So that's going to be equivalent to pi. I know at pi I had an asymptote, so I'm going to put my asymptote here because pi and negative pi are coterminal angles. And so I'm going to mark x equals negative pi. And now I'm going to go ahead and mark inside here, negative 3 pi over 4. All right. So we also calculated these values. So let's find these on our graph. So I know at pi over 2, cotangent has a value of 0. And I know at 3 pi over 2, which is a negative pi over 2, so cotangent of negative pi over 2 is also going to be 0. So what is cotangent at pi over 4? Well, cotangent at pi over 4, I have a couple of marks here. I mean, what we have on our graph right now does not give us any idea of what our graph is going to look like. But I do have marks on my, my unit circle for pi over 4 and 3 pi over 4. And I know at pi over 4, my cotangent is a positive 1, so I'm going to mark it as positive 1. I know at 3 pi over 4, my cotangent is a negative 1, so I'm going to mark it at a negative 1. So what is cotangent at negative 3 pi over 4? Well, negative 3 pi over 4, we're here at pi over 4. So that has a positive value, and it's positive 1. And at negative pi over 4, we're sitting right here. Okay, so that's in quadrant 4. It's going to have a negative value of negative 1. So when I finally graph my graph, you can see cotangent looks a lot like my tangent function, except it is flipped over the x-axis and the asymptotes are in different places. On a tangent function, they're at negative pi over 2 and pi over 2. On cotangent, they are at 0 and pi. So let's see if we can work in a problem or two, an example or two. Oh, let's take a look at the steps first. Steps for graphing our cotangent function. Step number 1, find all values of a, b, c, and d. So if your equation looks like y equals c plus a cotangent of b times x minus d, okay, if that's what your equation looks like, find all values of a, b, c, and d. If c is not 0, right, c is going to be your vertical shift. This is going to be your vertical shift. Make sure that you mark it on your graph with a dashed horizontal line and label the equation for that line. Step number 3, find the asymptote at the beginning of a period and at the end of a period. So in this case, we're going to set b times x plus d. We're going to set this right here equal to 0 this time. And to find the n, we're setting b times the quantity x, well, I think that's x minus d, I'm sorry, x minus d. We're setting that equal to pi this time. Okay, so that'll find the beginning and the end of one cotangent period, and those represent our first asymptote and the end of our period asymptote. Okay, so then you need to calculate the quarter, the half, and the 3/4 labels, write them on your graph, and plot points at these marks. Step number 5, calculate your period and check this against the width of your graph. So this should be, your period should equal the end minus the beginning that you calculated in step 3, and that should be your pi over b. And then plot another period if that's necessary. Okay, so let's walk through one example. We have a, b, c, and d. Let's calculate a, b, c, and d. A is 2, right? A is the number that's in front of our cotangent function. It's a positive 2. B is going to be the number that's in front of our x, which is going to be 3. C is going to be our vertical shift, so that's -1. And D is missing. So we have a phase shift or a horizontal shift of 0. So let's go ahead and take a look at calculate our period. Our period is going to be pi over b, which is 3. Okay, our vertical shift is our c value, and I like to use these instead. Okay, we have no phase shift. Our phase shift is 0. We're not moving it anywhere. Okay, and while this is not an amplitude, again, amplitude talks about the distance from your resting position to your maximum and your minimum points. This has no amplitude because it goes up and down to positive infinity and negative infinity. So, but we do have a stretch. Okay, we do have a stretch by a factor of 2. All right, so now let's go ahead and calculate our begin and end points. I'll do that in green. Our begin, we're going to set everything that we're taking the cotangent of, 3x. We're going to set that equal to 0 and solve for x. And then for the end, we're going to set that equal to pi, divide by 3, and we get pi over 3. So again, when we mark these out, I'll mark these off on our graph, we need 4 equal regions. Okay, so we're starting at 0 and ending at pi over 3. So I'm going to say 0, count out 4 of these, 1, 2, 3, 4. This will be my pi over 3. And remember, that's going to be our asymptote. we're going to find our vertical shift and label that equation. It's at -1. Y equals -1. Let's go ahead and graph our asymptotes. And you see how I kind of put the one down the y-axis a little off? That's so that we can see it. All right, so now how do we label the inside? Okay, half of pi over 3 is going to be pi over 6. Okay, the midpoint between 0 and pi over 6, you can add those and divide by 2, or you can think half of pi over 6 is pi over 12. So each of these distances is a distance of pi over 12. So this is 1 pi over 12, 2 pi over 12. This is going to be 3 pi over 12. And what's 3 pi over 12? I shouldn't have written 3 pi over 12. I should be writing pi over 4, because that's the simplified fraction form. All right, so now let's go ahead and calculate some of the values of cotangent. So the cotangent of 0, we already said that's going to be undefined, okay? And we have our nice little asymptote. What's going to happen when we plug in cotangent? Let's see, y equals -1 plus 2 times the cotangent of 3 times pi over 12. Well, that's going to give us pi over 4. Cotangent of pi over 4 is 1. So when I do this calculation, I get 2 minus 1 is 1. So pi over 12, I'm going to plot that point. Okay, we'll plug in pi over 6. And when we multiply pi over 6 times 3, we get pi over 2. Okay, at pi over 2, what is cotangent? Well, again, that's going to be x over y. So x is 0, y is 1, so we get a value of 0. So when I calculate that out, I get a -1. And now when I calculate the equation at pi over 4, cotangent of 3 times pi over 4, the cotangent of 3 pi over 4, that's in quadrant 2. I know the x and y values are equal magnitude but different signs, so I know cotangent is going to be a -1. So when I do this calculation, I get -3, and I plot that point. So now I'm going to go ahead and draw my graph. All right, so I want to go ahead and plot one more period. So I'm going to count 4 of these equal parts backwards. Okay, 1, 2, 3, 4. I know each width is pi over 12, so I'm going to start labeling them. This is going to be a -pi over 12. This is going to be a -2 pi over 12 reduced as -pi over 6. This is going to be a -3 pi over 12 reduced as pi over 4. And this is going to be a -4 pi over 12 reduced as pi over 3. So I'm going to draw my asymptotes. I know at the beginning of a period, I have an asymptote. X equals -pi over 3. And at the end, my asymptote is already there. I'm just going to copy my points directly over. So the quarter of the way through, that's this point. I'm going to copy at the quarter mark. Halfway through, that's this point. I'm going to copy at the halfway mark. And 3/4 of the way through, I'm going to copy at the 3/4 mark. And then I'm just going to draw my graph as before. Okay, and those graphs are identical. The width of each one of these is pi over 3, right? From here to here is pi over 3. That matches my period, so I'm good. Stay tuned for the next video to see 2 more examples.